I'm Anil Kumar, and in this video we'll further understand how to sketch polynomials and what end behavior really means. The question here is, sketch graph of a polynomial with following characteristics. Find a possible equation and then calculate its y-intercept. The two conditions given to us are, first one, x intercepts at x equals to minus 2 and 3. So there are only two x intercepts. One is at minus 2, the other one is at 3. And the next condition is end behavior is from quadrant 3 to quadrant 1. Okay, now what does that mean? Let me make a rough sketch here and then we'll discuss. So what we are saying here is that we have two x intercepts. One, let us say, is at minus 2, the other one is at 3. Okay, so let us say these are the x-intercepts for us, minus 2 and 3. And we are also given that the end behavior is from quadrant 3 to 1. So quadrant 3 is kind of like this. This is quadrant 3 and 1 means like this. Do you see that end behavior? When x approaches negative infinity, y approaches negative infinity. And when x approaches positive infinity, y approaches positive infinity. That is from quadrant 3 to 1. So this is one way of saying end behavior. Now let us sketch a polynomial satisfying these conditions. Now, since there are two x-intercepts, and if I go kind of like this, I'm not going to end there. So that means one of them should be kind of a turning point, right? So the possibilities are, keeping into mind that we have to go from quadrant 3 to 1. So we'll start from here and we could turn, right? And then we could go like this. So that could be a polynomial graph. Do you see? Continuous graph going through both these intercepts. Now if that is my graph, let me call this as f of x. Now we can write down equation of this function. We say f of x is equals to a times x plus 2 the first 0. Since it turns, we'll keep this order as 2, multiplicity 2. The other one is at 3, so factor will be x minus 3. So that could be the function which defines this particular graph, right? Now since we clearly see that the y-intercept is negative for us, that means if I substitute 0 here, we get a negative value. So what we see is that a is positive. Is that okay? The graph is ending here, a is positive in either case, right? So a is positive. Now depending on the value of a, we can actually get different values of y-intercept, right? So now I hope you understand how to solve such a question. Let's get back to it. Sketch graph of a polynomial with following characteristics. Two characteristics given to us are x-intercepts at minus 2 and 3, right? End behavior from 3 to 1, quadrant 3. This is quadrant 3, right? And that is quadrant 1. That is the end behavior. Find possible equations. So that is a possible equation. We can keep a as equals to 1 and then we can write, let us say our function be x plus 2 whole square times x minus 3. You can give any value to a, right? So there is a family of graph which is going to satisfy this condition. Therefore, find a possible equation, that's the possible equation, and then calculate y-intercept, this point. So we could calculate by placing x equals to 0. So for y-intercept, x is equals to 0, correct? So we'll write f of 0 as equals to 0 plus 2 whole square times 0 minus 3, which is 4 times minus 3 or minus 12. So this intercept is minus 12. So that becomes our y-intercept. You get an idea, right? So that is one way of doing it. Well, you could have actually sketched it like this also. That is to say, you could have gone straight here, right? You could have gone straight here and then turned from this side kind of like that. Do you see that? So that is also possible. You see, that is also possible. So this is the second function. So you could take that as an alternate solution. You can write now f of x equals to, we'll again keep a as 1, but the equation will become x plus 2 times x minus 3 whole square. Do you see that? X minus 3 whole square. And in this particular case, when you substitute 0, what do you get? You get 2 times minus 3 whole square, which is 27, right? Positive, times 2 as 54. So in this case, you get this point as 54. So in this case, f of 0 will be 54. So that could also be one of the solutions for you. But I hope with this you understand end behavior, x-intercepts, and how to correlate these things with the kind of equations we dealt with. We'll take a few more videos to consolidate on these concepts. I'm Anil Kumar. You can subscribe and learn a lot from my videos. Thank you and all the best.